Hi, and welcome. My name is Simon, and today I'm going to talk to you about something that's, I think, sometimes kind of neglected when talking about Clojure, and that's just how to get started on a large code project. And it's also, like, in some ways, like, for me, a rather personal topic. Like, I generally don't like starting presentations with this, like, about myself, but here I think that some just brief context is necessary. I kind of started using Clojure in 2010, and it's been my main language ever since. I've introduced it, I think, to at least 3 companies, if not more, and onboarded more than like 10, maybe 12 people to use Clojure, both novices and experienced developers. And I work kind of as a combination of data scientist, data engineer, and a backend developer. It's just kind of to give you a context from where I'm coming from. Though having said that, in all the past experience, I've always started every Clojure project from scratch. I've never joined a team with a pre-existing code base. That was until I joined Metabase. How many of you know Metabase? Woohoo! Okay, we have some vocal users in the room. Excellent. For the rest of you, we are an open source BI analytics tool written in Clojure, and the front end is JavaScript. Obviously, we're going to run on-premise or data agnostic. About 14,000 companies use us every day, and like our main kind of focus or differentiator is focusing on having a super nice UX and being very friendly. And that kind of also gives you a rough idea of the kind of various challenges we're kind of trying to solve. Incidentally, also, it turns out that we are the largest Clojure open source project if you count the vanity metrics on GitHub. But we are like, and it is also a substantial code base, roughly. By this morning's count, roughly 98,000 lines of Clojure code. That also counts comments, though, but those are kind of a pretty essential part. So imagine me, this like 2 years back, joining this project. It was slightly smaller at that point, but still a very substantial code base. So kind of where to start. And like this talk is going to be in 2 parts. The first part, was going to be like from the perspective of someone joining a new project or starting working on a new project. So just kind of and trying to recount the steps that I take where I found kind of that work and don't work and so forth, and the kind of various pitfalls. And then in part 2, we're going to look at the problem from the perspective of the project. So how can you make onboarding new people easier? How can you make your project nicer for new people to join? So let's get started. Well, first step, of course, is don't panic. That's always kind of a good thing to have in mind. It is, yes, it's going to be kind of complex, it's going to take time, but with a somewhat kind of systematic approach, just as we break down problems into small bits and pieces and solve them, like the same thing can be said of just how kind of mentally approach starting on a new project. So kind of the thing that I kind of like to do very quickly, this I suppose like somewhat depends on the type of learner you are, but I try to kind of get something where I can play with in my REPL as soon as I can. This kind of makes it, I see someone giving a thumbs up, so yes, I guess I'm not the only one who kind of feels just kind of completely naked and helpless without having something to play with in the REPL. So do kind of try to do that. If you like working on a complex project, that might be slightly harder than just kind of saying line REPL, because like there is going to be like some sort of initialization or something like that. And like this kind of scaffolding is something that is oftentimes a point of friction even once you already kind of are up to speed with the project. So kind of like worst case thing you can kind of always do is just figure out what lane run does, so basically what your main invocation is, and run this in your REPL instance, and just kind of essentially run the entire project in your REPL and then connect that. And you like in most cases, this is kind of actually what you want. You have kind of the entire thing you can test on and just send live code to your entire running instance. So even nowadays, like usually when working on Clojure, I'll just spin up a fresh REPL instance and just load the entire Metabase within that REPL and then have the whole thing at my fingertips. Doing so, there are kind of a couple of REPL-unfriendlies in Clojure in general, just kind of pitfalls. Like they might be kind of obvious, but it also turns out that you oftentimes kind of don't think about all the things at once, and especially it's kind of things that can catch you unaware, because like I think that for the most part, most people start working on a new project by getting some tasks, like fix some small bug. And that's kind of it's a good way to start in many ways, except for one, which is like if you're not entirely sure what all the code paths are, and you fix something, and the fix kind of doesn't seem to work, it's kind of then hard to figure out what's the reason, especially because there are some things, like if you do it through the REPL, where you might not be aware of. So, of course, definitely, like you just reevaluate a def multi in Clojure, it won't do what you would kind of expect because you'll still have the old, you'll still use the old dispatch function. The second kind of pitfall is if you use def instead of defen for functions. And this is like, I mean, I'll admit I'm like quite guilty of that because I tend to like partial and comp and so forth. So oftentimes you just have, instead of defen, you'll have a def for a function. And those kind of then, if those functions are called from other functions, and the definitions won't get changed. So again, you have kind of like stale function definitions floating around, which again, be mindful, just reevaluate the entire namespace or something. That also works. And last but not least, of course, also macros. And that kind of applies both in terms of like once, if you change the definition of macro, of course, you have to reevaluate all the points which we're actually using it. And also be kind of mindful of what the output of the macros you're using is. Because it might be that it will end up using something like def, and again, like, or will have some notion of state which will not be nicely updated once you're just going to rerun that part of the macro. So this is again something to be aware of if like you've made a change and it doesn't seem like this change took any effect. But like the big kind of offender, for instance, for kind of the last example is the prismatic schema, where if you have like a function decorated with the validators for the arguments, and you change the schema for one of those arguments, that won't kind of get picked up. You'll have to kind of reevaluate both the schema and the function, and that can be, I mean, it's annoying, but also it's a point of where you kind of aren't sure why you are getting different results than what you were expecting. And in general, I think like the kind of the biggest problem is like if you kind of try to break it down or put a finger to it, and like this touches on the kind of the previous problems I was talking about, is just kind of how to tackle deep pipelines in terms of like a long sequence of function calls which are going to produce the end result, in very likely kind of split across multiple namespaces and such. Like first of all, like hopefully you're dealing with stateless code. If it's stateful, that adds another class of problems and makes it even that much more gnarly. But even if the code is stateless, still you're not kind of out of the woods. One thing that kind of tends to be helpful is if you just draw a directed graph of namespaces. That will give you kind of this top-level overview of just roughly how components within your project tie together and what the kind of the very high-level flow is. Now, obviously, you also at some point want to look at what the actual kind of call graph is for coming to a specific function, but just to have this kind of rough mental model of what you're even actually dealing with, it helps to draw this. Now you can do this manually, and I think that's kind of actually just like a pen and paper. It's a good exercise because it acquaints you with all the parts, or if you're just kind of being lazy or wanted a quick fix, there are a couple of nice utilities like lane plugins that spit out a graph for you, which also kind of tends to be useful. Then kind of next thing that makes sense is to look at tests for those specific things, because like the thing is like tests will probably try to localize what they're testing, and will give you kind of a better feel of how you can jump very deeply into one that's kind of long pipeline and just test this part. And look at both of just kind of the arguments coming into tests and if there's kind of any kind of scaffolding being used and what the scaffolding does. And that will give you some kind of rough ideas of the steps through which you need to go through to get that part of code working. And the last bit is like something that's kind of, I mean, the idea has been, I guess, around since the programming languages got the print statement, but it's going to become slightly more useful and formalized in Clojure 10.10 with the new tap command, which allows you to kind of, like how many of you have seen that Clojure 1.10 comes with the tap mechanism? Okay, just a couple of you. So kind of a brief recap, it's kind of sort of the printf debugging, but done right. So you can define a number of taps which will consume what the tap command sends to them, and you can use that either for kind of nice printing or accumulate it in some way. And it just kind of makes it slightly more convenient than just printfing things, because it becomes more deterministic, and you can decide where to spit it out. And especially like with, I don't know, Metabase is one of those projects where we do a lot of logging anyway, and then if you just use printf debugging, it can get lost in all the other things happening. So tap is kind of nice in that case because it isolates that, and you can choose where it will spit out the things. But you can also, this kind of being Clojure, and then tap, instead of working on essentially string level like something like printing out would do, works with any kind of data, rather data structures. So we can actually build some kind of nice things around it. And one thing I want in all my tools ever since I saw it, and this is a tool built for Onyx by the people developing Onyx. Like Onyx is some Clojure stream processing framework, and they build this tool where you can just like real time at any point in the kind of the processing pipeline, if you can change something, it will just show you how all the then subsequent stages of the data also change. And this is like a super neat thing. Sadly, it's only kind of relegated to the Onyx world, but it's something that I would definitely kind of want to have everywhere. And it turns out that this being Clojure, it's not very hard to get like a lo-fi version of that going. In this case, for instance, using tap. So the idea is that we'll just kind of have an atom in which we'll store all the kind of intermediate values that we produce, and we can then kind of inspect that. So this is kind of the entire code that builds that. We'll have an atom in which we store it. Then and this is kind of the add tap thing is the new stuff coming, new stuff from Clojure.10. We said, okay, that we're defining a new tap, which what it does is it just, which is a function of an argument, and what it does, it just adds that to our atom. Then we do some macrology. The first macro, the tap starting, makes tap slightly more, I guess, convenient to use in a debugging-like context, because the two things we'll do is that, it does kind of three things compared to the normal tap. We'll add the name of the function which is currently being run by some horrible hack in doing like and stealing it from the stack trace. And we'll return the actual value so we can use it in threading macros, which I'm kind of a big fan, and it always hurts me when things don't compose nicely with threading macros. And unfortunately, the normal tab just returns true. And the last thing is just kind of consume any number of arguments. And then the second thing, we'll have a different version of the threading macro, which spits out all the intermediate steps. And with this kind of thing, you can then change your gnarly threading code with using that, and you'll see that you can then, if you inspect the value of the snaps of the our atom, we'll get all the kind of values as they changed when the code is running. And kind of the nice thing about this is, and why this might actually be in some cases better than using like a proper debugger, is that it's all kind of just all in Clojure land, and it's just data, so you can kind of freely filter over this or have kind of additional functions or validation. So even if you run this on something like very complex and you record the results of thousands of steps of computation, you can then manipulate that with Clojure rather than just kind of having to manually scroll through or something like that. So it's like a quick and dirty tool, but it turns out it has a lot of usages in just in how it makes kind of the transformations you're making more presentable. Now, since we were kind of started with macros, I guess these are worth commenting on. And it's kind of, I suppose, that in this context of just getting to know a new code base, it holds the same as with most Clojure. It's kind of this love and hate relationship with macros, because on the one hand, what they do is that they hide a lot of kind of boilerplate and incidental complexity, and that's an awesome thing when trying to figure out something new, because there's so many less things you have to think about, and just kind of makes the API that much cleaner and that much less things to think about. But it is like a very good example of this kind of something that's easy, but it's not simple. So kind of beware of the edges of magic. So because like oftentimes like the way probably most of us approach using macros is kind of by pattern matching. So you see how it's being used in other parts, and it's like, okay, so it's kind of, it should do that, rather than looking at definitions, because especially like macro definitions aren't always like the most readable Clojure thing in the world. But if you just like do that, sometimes you kind of might assume that the magic goes slightly further than it does, and then you kind of end up with unexpected consequences. Like a personal story, it's kind of took me ages to figure out what I'm doing wrong, because like in Metabase we have this macro for defining endpoints, and the macro is smart. If you have an argument that's named something dash ID, it's going to say, okay, this is an ID argument, and it's going to do like the coercion to a number, because it knows that it's an ID. But if it's ID dash something, or like a slightly different name, and you just kind of, you think that the magic is slightly more powerful than actually is, and those aren't then coerced, and of course the whole thing doesn't work. So kind of be careful, but like small things when it seems that it should work, but it might not, because kind of the original intent was kind of different than what you're trying to do, and it's kind of easy to just get it wrong. So, and kind of now I guess the more even personal part, when to ask for help. This is something that I've kind of been struggling with for a long time when kind of joining Metabase. And like, I was really kind of hoping when I decided to do this talk that this is going to be like the point where I'm going to distill all my reflections and come up with a good answer, but like sadly I still don't really have a good answer to that. It seems it's kind of, and I think it's like the more kind of experienced you are, at least like nominally experienced you are, the harder this becomes because you feel that like this is kind of sort of inappropriate for someone of your experience to go asking stupid questions. At the same time, like those are kind of the questions that are kind of stopping you. But if you don't ask those questions, you then fall into the trap of spending way too much time for something that should have been kind of simple, and it is simple, just because you don't know how to approach it. And again, it kind of, you end up being frustrated with yourself and feeling that you're underperforming and all those things. So again, kind of an unhealthy situation either way, and yeah, it's hard to strike a balance. But like what I can kind of offer you is just how to ask kind of good questions. And I mean, this is kind of a, I guess, pretty general, and if you've ever been screamed at Stack Overflow for posing a wrong question, like somebody will pop up with something roughly like this, but still worth repeating. So when asking a question, do give kind of a context or the task, or like what is actually you're trying to do, and the approach you're trying to take, not just one or the other, but kind of both. Because like, and oftentimes we just start with, okay, I'm trying to do that, but not giving a context, and it might be that you're approaching the problem fundamentally wrong, and it's kind of very helpful if the person you're asking can kind of catch that and help you avoid the pitfall. So we give the context, give the approach, then actually ask the question itself, like how do I do this, or why doesn't this work, or whatever. And last but not least, like also kind of point to the code. Be considerate enough that you can kind of point the code, save the time. And also it's kind of in a way, I think, at the very least, it's a checklist of the things you should kind of understand before asking questions, unless you're like kind of completely lost, but otherwise this kind of feels like a decent hygiene of kind of trying to figure out at least some parts of kind of isolating the problem enough that you can pose the question and then from now on ask the question. And yes, regardless, like you will often kind of feel dumb, and I think that's kind of that we all do. I mean, or I'm just kind of hoping that we all do, because I certainly have done that oftentimes kind of in the past. And I think like we shouldn't kind of shy away from it. So I know for myself that like for the next project, if that comes to be ever like I will be joining or the kind of next contributing to, I will definitely kind of err on the side of being dumb, because inevitably like you end up kind of feeling like that anyway. So just kind of try to make it kind of as efficient as possible, and don't spend like empty cycles chasing your own tail when you are absolutely lost. Right, that's been kind of the part one of this talk. So some of my reflections on just kind of how to get started, and some hopefully useful tricks, or just like how to think of the problem. And now from approaches from the other side, like how to make your project easy to start on. Well, like the first one is, of course, have documentation and have good documentation. Like this is one of the things that Metabase is kind of really awesome at, because we have plenty of functions with extensive comments like this. And that really helps you. I mean, not even just at the beginning, but just even now when I'm stumbling to some part of the code that I haven't really interacted with, things like this like help immensely. And it's worth emphasizing that it's not just about like docstrings on functions or whatever kind of symbols, but oftentimes I also find it very important that you have this kind of holistic docstrings on a level of the entire namespace, or at least like a chunk of functions, something like that. And those tend to be much more useful because they show you the overall intent rather than kind of being separated by function to function. And like the difference here is that if you just read the docs or rather organize your docs on a per function level, like a lot of the kind of the logic of how things fall together is kind of implicit just in the call graph, rather than being explicit or just hidden away by the overall point. So that it does make sense to oftentimes have big, nice docstring comments. So kind of a couple of things that make docstrings good and useful is have examples. Just kind of the things that you should generally be able to just evaluate, and it will pop out something useful. Reference any kind of related functions that you're using, or just kind of are tightly interconnected with that. Link to, like code that's algorithm heavy, like doing some number crunching or whatever, just like implementing some algorithm from somewhere, have a reference to where you've picked up this, or like based on what did you write the algorithm. I think that's kind of a much better approach than essentially just copy pasting the description from somewhere else, because let the reader then decide what's going on, or even maybe dig deeper. Make sure they're up to date. I know this kind of, again, generic thing with comments, but it's very easy to have kind of somewhat stale docstrings when you do kind of small changes and add maybe an additional parameter or something, and then kind of and this has kind of, I mean, it's not just that the docs aren't up to date, but the bigger problem, I think, is that it, especially like when you're a beginner, it somehow shatters your confidence in the docs, and that has a much more profound effect than just being like somewhere factually wrong, but having like this, knowing that this is not as good as a safety net as you were hoping to be, and you were like so glad when you saw this extensive comments, and you're like, oh yes, this is going to make my life so much easier. And then you see, okay, but this doesn't hold. So where else is like, was the doc wrong, and am I wrong because of that? So kind of don't curse your readers with that kind of then constant questioning. And the last thing, this is kind of, I guess, somewhat working around one of the, in some contexts, the efficiency of Clojure, tell about just the shape of data coming in and out if you have some like more complex data structures. This, again, is kind of useful just in terms of how to use it and what are the expectations of the things being pooped out. On this topic, also kind of validation of all public interfaces is something like all the public vars in a namespace makes very much sense in a kind of a large project. Now, what you use here, there are tons of options, but like it seems that most people either set up on schema or on spec, and like we use, like at Metabase, we're using schema, but I think that's kind of mostly for historical reasons rather than thinking that a schema has some strong pluses. And actually, like it does, if you just kind of compare these two side by side, spec has one very important advantage, and that's that it doesn't suffer from what I previously was talking about, how like you need to, if you redefine a schema, you also have to reevaluate all the functions using that schema, while with spec, the way it's done is more conducive to kind of to this very dynamic REPL nature of doing Clojure. So you can just update the spec definition, and like the right version is going to be used. And when you have kind of very complex schemas, or using a lot of the different kind of validation schemas, that kind of help immensely, because otherwise you're kind of chasing all the instances where you're using one schema over your code base and revalidating all those, and that's kind of annoying and error prone. So like the validation doesn't, I think the value is not just in having validation as such, but also just in being there as a kind of documentation that you know is correct about the shape of your data coming in and coming out. But of course, like the trap is that oftentimes it's overly specific, especially with things like, is a null here fine or not? And we kind of oftentimes are going to tend to err on being like too specific, so that's something kind of to be mindful of. But at the same time, like when it is important, it's kind of very nice because it can catch errors very soon as they happen, rather than somewhere deeply down the kind of the pipeline. So if you produce a nil somewhere where you shouldn't, and like it's very nice that the whole thing explodes at that point rather than 5 functions in when something that actually doesn't know how to handle nil, because all the other functions in between are kind of flexible enough that they do nil punning successfully. So, and validation kind of pushes that closer to the actual source of the error, which is immensely helpful in kind of figuring out what's going wrong. Do keep in mind though that kind of any form of validation does have a performance cost. So if you have something that's performance critical, it's like sometimes you will have to do without kind of doing validation or move validation somewhere else because it's just like too slow. And I remember like a case like that very early on my time at Metabase, where I was slightly too eager with putting schema to everything, and this kind of something took way longer than one would expect, and it can turn out, oh yeah, that's because the kind of cost of that. So be mindful. Of course, the ying to start REPLing early is make code REPL friendly. And that's kind of, I suppose, every Clojure code base is pretty REPL friendly just by virtue of being Clojure, but there are differences in terms of how you manage things like setup of various components, like especially in a complex system, and all the kind of the scaffolding around this can be more or less REPL friendly, and here it does make sense to kind of spend some time thinking about those things. And also just document how to get like a REPL environment running in terms of not just writing lane REPL, but all the kind of bits and pieces you need to do of some sort of initialization or whatever to have a REPL session, and also like making sure for what state you have, kind of how to manage that state, how to kind of, if you need to start afresh, what's the best way to start fresh, and things like that. All those kind of will make it much more nicer for people starting, and will also kind of, especially in terms of just kind of component lifecycle management, they will also prevent a class of bugs that otherwise happen. Like you think you've solved something in REPL, and then you commit the code, and it doesn't work just because you had some kind of stale state somewhere. So do kind of help people with that. One thing I like, although this is something like we haven't tried much yet at Metabase, but I was pretty happy with how this turned out in a couple of my previous positions, is to use notebooks. So something like either Jupyter or from Clojure land, the Gorilla REPL or the Clips, to onboard people, because like the thing that a notebook does, this example is from Clips, is that it allows you to kind of intermix obviously text or documentation with code, and code that you actually can evaluate with. So you already, by writing this out, you break out the problem, and you can then kind of allow people to just experiment and change small little bits in that piece of code and see what kind of effect that has, and kind of guide them through the whole thing, but in a interactive manner. And I find that kind of a very important way to start. And it's also like, because a notebook is kind of a living document, you also, like the person who wrote it presumably took care of all the kind of initialization, and all the kind of components are in the right place, so you can just kind of start building off of that. And that immensely helps just kind of in people's confidence. And especially I think this is important for people coming from, who are new to Clojure. And because it makes Clojure much less scary that, first of all, like you don't have to also, and by the way, set up Emacs as well, which is kind of a shitty way to start doing Clojure anyway. But here's like, you have like a very small chunk of code with which you can kind of interact, and that's kind of for what you're thinking about, that's kind of your entirety of your universe is right there, and you can just focus on that rather than having to have work on a level of source files or just kind of a REPL session. And kind of the nice thing is that also like notebooks do allow you to have this kind of progression and organizing things, and are fixed, right? Because like you can't really kind of share a REPL session with someone. Like previous, like REPL is completely ephemeral, which is probably like in this kind of context, like its biggest downsides, while the notebook does capture this entire kind of flow of how you do something and kind of slowly build up to the final solution. Also, like I guess this is a general code hygiene, and like, but do kind of write small single responsibility functions. And this, like, why is this especially important when you're talking about onboarding new people? Is that it helps, like there's a limit to what you can hold in your head. For me, I found that it's basically like one screen full, maybe two if I'm feeling especially enlightened that day and really sharp. But like in general, like to be on the safe side, like I can feel a screen full of code in my head and kind of think about that. And it can be more just kind of, it becomes harder to reason about. So in kind of smaller functions do allow you to kind of isolate, this like mentally, the part of the problem you're working at without. And it also, because it's kind of single responsibility, each function tends to be used in less context, in less code paths, ideally just like one code path. So it's less often that you're going to have to refer to, and you can focus more on every kind of chunk of what's doing. And like those kind of small things, I think like help immensely. And it's something that in general, as programmers, we don't, I think, spend enough time thinking about. It's just kind of the mental side of how we develop, and the kind of the mental models that we build around our code, not the mental models we try to write in code, but rather the mental models that are supporting are just kind of the operation of actually writing new code, and how those interact with our choice of tools and things like that. And they do make immense difference in how easy or not it is to start something new. On a related point, good namespace structure also kind of aids understanding and focus, because again, like there shouldn't be things that, like, if you have some very different functionalities, like, there's a good chance that it makes sense to split them across different namespaces. If for nothing else, just that you're kind of, when opening like a single Clojure file, that there's less thing going on, and you don't kind of have to figure out like, when is this important, or is this important at all to me? But you know that like most of the things you're looking at are things that are important to what you're trying to do, and actually going to be used in some way in the code you are looking at. And it's kind of focusing and guiding you is very helpful. And also just kind of the structure, as we previously said, does like namespace structure, I guess, is the first insight for you into how the overall project is shaped. Also, like one thing that, and I guess this is going to be like a critique of what we have at Metabase, is that like test scaffolding and utilities should be kind of designed just as carefully as the rest of your code. This is, I mean, like, I think like most like projects kind of suck here because we tend to like write the test utilities as something to kind of to remove the tedium of writing tests rather than kind of something that's going to be kind of reusable. And then this, but at the same time, like the scaffolding you do with testing is very often has to do with kind of component life cycles and things like that, which are kind of tricky to nail. And it very often kind of you end up with the entire kind of test infrastructure that you have in place that's not very kind of flexible, and then you have kind of someone new trying to do something new, and you then have this kind of a double of first kind of figuring out like how the scaffolding even works, and then oftentimes it turns out that it's kind of, it doesn't really fulfill the task you want it to, because it's been written too narrow-mindedly for kind of solving someone's pain, and then you kind of either have to kind of redo a lot of it, or just kind of duplications of like very similar things, where it kind of feels that this part could be, if it were more cleaned up, it would make kind of writing tests easier, and also like both writing and just kind of understanding what's going on, because like tests are a good way of showing you kind of how you use that kind of code in anger, or like both for the libraries, or from the perspective of projects, how you can kind of decompose the entire of the pipeline into kind of smaller chunks. So like it does have this strong function of communicating that as well, and if that gets kind of hidden by how you use and abuse the kind of utilities around testing, that's a shame and a lost opportunity. So in terms of tackling kind of complexity, try to kind of push as much code as you can to outside projects. So either kind of releasing things as standalone libraries, or ideally contributing to existing projects. Like why I think that contributing to existing projects where it makes sense is a better choice is for kind of two reasons. One is that means that like you're using code that there is a chance that new people already kind of know, so they're kind of more familiar with, and of course there's kind of this effect of more people kind of working on it and building on it, rather than you being completely responsible for it. But any way I suppose like any way you can reduce the number of lines of code that you have is like one thing less that you have to think about, and one thing that's kind of very well confined, and you can just stop thinking about it, and that always kind of helps. I've already kind of hinted at that, but kind of the workflow that you have if it heavily depends on extra tooling, that's an extra cognitive burden that is going to hit new people really hard. And that's kind of, I mean, if you are a shop that predominantly uses Emacs, that's something that is very easy to happen, because everyone will have like a bunch of different helplets written in Emacs, and I think it's worth kind of from time to time doing kind of an introspection of the kind of this ad hoc tooling you've built around your project, and think like, does this mean that maybe like some of the affordances of the code itself are problematic, and we should rather focus on that instead of just kind of bulldozing over it with a couple of crafty Emacs macros and be done with it? Because having to kind of like, the more kind of moving pieces you have in terms of all the kind of tooling you need to set up and how you need to set up, the harder it is for someone new to start using your project, even if they're Emacs user to begin with. Also, kind of having a well-defined coding style, I think, is something that's kind of helpful, not just because it's kind of easier to read, everything is unified, but I think it has this kind of I suppose, hard to pin down quality to it, that you feel that you belong or something when you're kind of doing when you're conforming fully to the coding style. You know, it makes you part of the tribe of that project. I don't know. Before starting Metabase, I usually put the function arguments kind of on the same line as the function definition. The kind of Metabase has a different way, and we also kind of use more aligning of the code blocks. And it just, at first it was kind of, I didn't kind of do it, and then like in code reviews it was pointed out that like it should be done differently, and it's kind of like maybe for the first week or two was kind of annoying, to be honest. But now it kind of, but then you start doing it consciously, and it feels like, okay, now I'm really now I'm part of Metabase. And I know it's a super small and silly thing, but I think like those kind of having well-defined kind of behaviors around how we do code, it is important just kind of to feel part of the team, and it also, of course, helps legibility at least somewhat. Also, on a more kind of a technical sense, like do use a linter and write kind of custom ones for additional things. That I think like this kind of has two functions. First of all is that it's well, it increases code quality obviously, but it also like in terms of just onboarding new people, what it does is that it saves some of the kind of potential embarrassments or frictions for new people, because they can just like run the linter on their own and only kind of fix those things that would come up at code review. And also, you don't waste time talking about stylistic things during code review, which then like often this is one things where like a lot of code reviews go down this kind of wrong path where we just kind of talk about style and superficial things instead of kind of focusing on what's actually kind of being done. And the linter just kind of removes that, because the moment the linter says, okay, you know that it's kind of going to be kind of compliant with that, and just removes a huge class of coding issues. Like, I don't know. I remember at Metabase, like we had this rule that namespaces should be ordered alphabetically, and now we have a linter for that, and it's great. But before that, like I remember, like almost any PR that we got contributed, like one of the code review comments was, okay, like can you please rearrange the namespace declarations so they're in alphabetic order, and that just adds needless friction that shouldn't be there and wastes time where it shouldn't be. Of course, speaking of code reviews, do them often, do them properly, reserve time for them, not just kind of be something that you stuff somewhere in the day, but plan them in stand-ups and so forth, and actually kind of try to be as helpful and obviously as open as you can. And last but not least, overall, like have a well-defined onboarding plan, and that also kind of including both just all the kind of the things you need to set up and how to start a REPL session, how to kind of manage the life cycle of all the components and those things. But also just in terms of, okay, what kind of tasks are we going to give to the new person coming on board? Where will they start? And are those tasks kind of actually like a good didactical aid, or will they then kind of immediately hit a wall because there's like this kind of massive complexity hidden behind something kind of potentially simple? Like, do think about those things. For instance, like I love how Rustlang has like a special section of their issues which are tagged kind of beginner friendly, and someone kind of goes and says, okay, this is a good task for someone wanting to join this project and working on something and do that. And I think this is kind of something that definitely most large open source projects should adopt, and also just kind of in terms of internally kind of have a good understanding of which tasks make sense, and maybe even kind of have a backlog of those tasks and intentionally defer doing them if you know that you're going to kind of be hiring soon or adding new people, and reserve it for using as this kind of onboarding tool. And kind of with this, I leave the floor to you if you have any questions, or if you just kind of want to experience the onboarding process anew. We are hiring, so do come to talk to me if you want to work at Metabase. It's awesome. Ask any questions you have either now or track me down at any point during the conference, and like I'd love to help any way I can. Thank you. No questions? I'm told that you have to walk to the microphone to ask. But
do you recommend any of the tools like component or mount?
If any, I would kind of pick mount just based on the kind of design philosophy, I feel, and then this is going to be controversial probably, but like I'm not a huge fan of component. I think it's rather unclosure-y and too kind of Java-ish, for the lack of a better word. I think mount is closer in the spirit of Clojure, but at the same time, I also, like, to be honest, I haven't seen any of those tools that kind of are a good fit for everything. Like, my kind of, just like my hunch is that nobody has kind of decomposed the problem enough in this kind of rich, hickey sense to kind of define the actual building blocks you need to kind of build all those things around it. So every time it's more of a framework than something that can be lightweight library, which just feels like in terms of the where it structurally fits in solving your problem, it should be like a lightweight library rather than a framework that then forces you to reorganize all your code around it. And I think that kind of oftentimes causes friction.
Do you have to teach people Clojure at Metabase?
I don't think we've had that case yet because, but Cam, my coworker, can correct me if I'm wrong, but I think like all the people working on Clojure already knew Clojure when joining, but that's not a hard requirement at the moment. I have taught Clojure in like a couple of previous positions, both to data scientists who had almost kind of no programming experience, as well as like developers from different walks of life, both kind of Scala and other function language people, and just like people versed in Python or something. So to be honest, I think that Clojure is one of the nicer languages to teach people because it just kind of especially like you can get very far in the language without encountering any kind of like super unintuitive behavior. I guess as long as you have like a sane environment, and that's why I think like notebooks are fantastic. Like if you give someone a notebook with like a functioning Clojure environment behind it, like they will get very far and they will encounter very little weirdness or unexpected things. It's basically just parentheses, but like those are already kind of solved by just the tool. So from that perspective, I think like it's very easy to get people to use Clojure. There was another question somewhere there.
Yeah, I guess your talk mostly covers this, but I'm working in a company. We're trying to introduce Clojure. A lot of the devs are C# or imperative languages. Do you have any tips on how to initially propose the idea of considering Clojure as an alternative? Very broad.
I guess that depends on the organization. Like in some cases where I introduced Clojure, it was just kind of this like I know that I can be so much more productive in Clojure, but that was like because I was kind of at that point essentially like a one-man band with this prospect of assembling a team to do like this thing, and just like what we need to do is like in the time we have allotted, there's like almost like no way to do it. But if there is a chance that we can do it, like the best chance is going to be to use the tools where I'm kind of, or the team that we have will be the most productive in, and I thought that that's kind of Clojure. So that's kind of purely from a perspective of productivity, I think is a good approach, especially like if it's a small team, like a self-contained, and why I emphasize this is because I think it's kind of the least technical. Like other arguments are kind of technical. Yes, Clojure is rather good at manipulating data structures and so forth, but like realistically, like oftentimes not all your stakeholders are going to be kind of impressed that it's darn good at manipulating maps and things like that. While this is kind of something that's pretty clear, and I guess also like if you aren't already a JVM shop, it's also okay. Like it opens up the entire JVM ecosystem, which like inevitably like most will clash into it, at least like by virtue of having to use something like Spark or Kafka or something, or AWS. So it's kind of like it tends to have like it covers a lot of your bases, and again like with kind of nice productivity, and just also think like being like super interactive, which is also something that you can show. Like I remember do you remember like one of the first demos? I think it was for Reagent. Was like super interactive, and it's like a super simple thing to do, and it just looks so good because you can just change things in the code, and immediately the change shows in the browser, and that's something that's very kind of plastic and visceral that you can show to people. Say, okay, like this is what Clojure allows me. Now think about like how the entire life cycle you need to go through with something like C# to compile it and everything around it. And here I'm just kind of typing code and evaluating just a small chunk, and it's going to change behavior live on a system. Now, and that allows people to imagine how kind of different the development is and how some things might be kind of much easier, and gives more credence to your claims that you can be super productive using Clojure.
So most open source projects are typically libraries rather than like large applications like Metabase. And so I'm wondering, can you give an example of something that Metabase does well in terms of allowing like a new contributor to actually understand the entirety, or like be able to actually contribute, because a large project usually is like way more complex than like a single use, like specific use library?
Oh, like to be honest, like we're pretty bad at this currently. Like our the way we are shepherding our open source ecosystem is, well, it leads things to be desired. We still have like this mind-blowing number of contributors, like 140, 190 or something like that. But like to be honest, like many of them kind of are contributing kind of despite our lack of efforts rather than because of any kind of concrete. And this is an approach that this is an area that we know we are lacking and definitely kind of need to improve. So yeah, that's why if you notice through the talk, it was kind of mostly focused on my experience, and I was trying to kind of generalize it to any kind of Clojure application rather than specifically talking about the Clojure open source project, because I don't think like we are a super good example here. Like we know that we suck, and we do intend to kind of improve. But yes, there is like, if you want kind of a good example of that, like the Rust language I mentioned, like I think they're doing a lot of good things. Like they actually have people dedicated to shepherding kind of people onto it, kind of making them bigger contributors. Like there are some nice examples, but in general, I think like a lot of the open source world could kind of improve that. But I suppose that's kind of the same thing as with UX, when we just kind of the projects that are completely just contributor run, and then kind of tend to do the things you kind of find interesting rather than something that's kind of slightly dreary to work on. And that's why you kind of have not so good UX either on the product side or on the side of just joining the project.
Hey, so I was wondering if you might say a word or two on your view of the suitability or lack thereof of Clojure specifically for data science and data engineering, and what do you think we should be doing to increase our outreach into those communities?
Okay. A long time ago, I actually had a full talk on this. And I do apologize to everyone else in the room who might not be interested in the topic of data science. Like I'll try to be like super brief, and you can kind of track me down later, and I'll give a more extensive answer. But in general, I think that Clojure is very well suited to this. Actually, I think that this could be one of the bigger kind of directions of growth for Clojure, and the reason for it is kind of like the main two ones are, or three. One is that when you critically look at what data scientists will do, is that like 80% of your work is not going to be algorithms, something like that, but it's just going to be kind of cleaning and manipulating data and figuring out like what's happening, or maybe why something is going wrong. And Clojure, by virtue of being like super interactive and very good at manipulating data, is great at that. Like it's much better. Like if you just need to manipulate data, it's a much better language than in something like Python, which tends to be kind of or R, which are the two main competitors, I suppose, for this crown. And at the same time, but also running on the JVM, it's still like, it is much faster than something like Python or RR without kind of without dropping down to C. And that's also like, I think, because again, yes, you'll have a lot of people working on like super huge data sets where you are running this on some Spark cluster anyway and don't care. But I think that for kind of a lot of working data scientists, it's still kind of important, what can you do kind of on your laptop and without kind of too big of interruption in your workflow, meaning that like it doesn't matter if something runs in maybe like 2 seconds or 20 seconds. That's kind of a important difference just in terms of your, I guess, developer satisfaction and like how often you kind of run things, how interactive your entire workflow will be. And the kind of Clojure seems to be just kind of fast enough that if it's kind of awkwardly sized data which you still can work on your laptop, it tends to be kind of fast enough, while Python with something like pandas tends to kind of break down on the larger end of things. And just I think that the third reason is that Clojure is fantastic for kind of building tooling around this. But this is something that's kind of completely unexplored until now, or still. And I think it's kind of a big shame. But it's very easy to kind of build kind of very specific tools around Clojure, just kind of inject them somewhere, maybe like worst case just as kind of an REPL middleware or whatever, like somewhere in that chain, and kind of build tooling around it. And a lot of kind of data science work would benefit immensely for having kind of various kind of tools and gadgets to help you analyze data that's kind of very domain specific with what you're doing. And you simply don't have like this luxury elsewhere. So that's why kind of the data science process tends to be, I think in a lot of ways, if you look at just kind of abstractly of how data science or how we teach data science, it reflects way too much the limitations of the tools that are currently being used rather than just the actual nature of the problem. And that's again kind of, so that's why I think that tooling has a huge potential here, and Clojure is a great tooling language. But more on this kind of one-on-one. There's another question here somewhere. Okay, so thank you.